In this lecture, we are going to discuss a very important topic in class 12th physics, that is electrostatics. We will first start with the literal meaning of the term electrostatics, and then we will go and discuss the physics behind this term. Now, electrostatics is unit 1 of class 12th physics, and it covers first 2 chapters in class 12th physics. So let us move and understand the literal meaning of the term electrostatics. It can be broken down into 2 words, electro and statics. Electro refers to electron and statics refers to at rest, where electron is a charged particle. Now we can conclude that from this discussion that electrostatics means charge at rest. So this is the basic assumption which we have to consider whenever we are studying the topic electrostatics. That is, whenever we are studying the first 2 chapters in class 12 physics, we have to consider this assumption in the back of our mind that charged particles should be at rest. This is the basic assumption. Now let us understand what charge is. So to understand charge, let us first understand mass. Now mass is an intrinsic property. It is a property that is internal to a body or particle. Similarly, charge is also an intrinsic property. It is inside of the body and it comes by the internal effects which are taking place inside the particle. As the mass is defined as the charge or matter contained inside the body. Similarly, charge is due to the internal effects which are taking place inside the particle, and we will define it the following manner, that internal property of an elementary particle. This way we define charge. Now what is an elementary particle? We will discuss it now. A particle which cannot be broken down into smaller particle is an elementary particle. The example of elementary particles are, the most common example is electron. An electron is defined by a symbol E and a minus sign attached to its top. So this way we can define elementary particle. Now electron cannot be broken down into smaller particles. Now in physics we mostly deal with physical quantities, and we have to understand that either they are vectors or they are scalars. These physical quantities are either scalar or either vectors. So charge is one of them. We will define charge also, that charge is a physical quantity and it belongs to the category of scalar quantities. Now charge have SI unit. Since all physical quantities has SI units, so it has SI unit as coulomb, which is denoted by a capital C symbol, and the symbol that is used to define or used to state charge, that is Q. Q is used to signify charge. Now we will define or we will state how many types of charges do we encounter in physics. There are 2 types of charges. First one is positive charge, which we denote as plus Q. Second one is negative charge, which we denote by minus Q symbol. So these are 2 types of charges which we encounter mostly in physics, or we can say in electrostatics. Now we will define electron. What are the charge, or what is the charge content of the electron? Electron is having minus 1.6 into 10 to the power minus 19 coulomb. This much amount of charge is contained in a single electron, and sometimes it is known as electronic charge. So basically we have covered most of the things related to the topic electrostatics. Now we will consider two important properties related to the properties of charge. First one is the additive nature of charge. Charge has additive nature. Now what does this mean? We will understand this by the help of an example. Let us consider a body having three charges, 5 coulomb, -3 coulomb and -2 coulomb, and we have to find the net charge content of this body. So in order to find the net charge content, we will just add all these charges numerically with their signs respectively. So +5, -3, -2. So the net charge is 0 coulomb inside this body. Or we can very well replace -2 by let us say we have another example. Here we are having a body with +5 coulomb, -3 coulomb and -8 coulomb. We have to find the net charge content of this body. So the net charge content would be -6 coulomb. We have added all the charges, or we can say that we have added all the numbers. So this is the additive nature of charge. Now we'll understand another property of charge, that is quantization nature. To understand the quantization property of charge, we will see through an example. Let us consider a body which is having a charge of 16 coulomb. We can say +16 coulomb. Now we have to find or we have to define quantization. Quantization is defined as Q. Let us consider that Q is the charge content of this body. Q is equal to N times E, where N is an integer and E is the electronic charge. So Q, that is the charge content of this body, can be written as Q is equal to 16 N times E. E is equal to 1.6 into 10 to the power -19 coulomb. So N is equal to 10 into 10 to the power 19. Now this thing will come on to the LHS and we will get this particular thing. So N comes out to be 10 to the power 20. So from this discussion, from this whole mathematical thing, we conclude that 10 to the power 20 electrons are present in this body. That is, charge inside this body is distributed in small packets, and each packet contain this much amount of charge, that is 1 electronic amount of charge, and there are 10 to the power 20 such packets. So this is the quantization nature, that is, charge is quantized in this particular format, that this particular amount of charge, 16 coulomb, is quantized in small packets, and each packet is containing this electronic charge. So this is the basic discussion about the topic electrostatics.